not all these guys were here for your talk in the morning, so I wonder if you could give like a 30-second summary of what you guys are doing with sequencing at Houston.
We're developing a read-length unlimited DNA sequencing technology based on directly imaging heavy atom-labeled DNA molecules. And we aim to have something on the order of whole human genomes that are more or less totally complete and 6 nines accurate for very low cost by 2015.
Yeah, so from what I understand, they're taking a kind of image processing based approach to genome sequencing. They kind of stretch out the DNA and take a picture or sequence it, which is quite different than the standard molecular biology approaches. So I wonder if any of you guys have any comments on like what if they succeed at this technology, which they seem to have some indications of doing. What do you think would the implications be? Any other?
Hi, I have a question. How do you treat with DNA before you do the sequencing?
How do we treat the DNA?
Yes.
Direct chemical labeling with heavy atom containing molecules that provide a contrast agent. I can tell you all about it later.
Okay.
Go into as much detail as you like. But one of the beauty parts of it is no limitations on read length. So we expect to be able to truly complete the human genome and to not have any problem with large-scale structural variations in cancer genomics, for instance. So, and we think the only other next-gen approach with a chance of doing that is nanopore. But we think we're significantly ahead of nanopore in terms of proof of concept. So I'd like to bring that to BGI.
Very interesting.
Thank you. But I guess so my question is, you guys do a bunch of next-gen sequencing work. Now, what if their technology works? What does that mean for the kind of work BGI does? What are the implications?
I mean, we are open to any new techniques which can do sequencing for the a lot of species. And we actually, I think there's a new technique called optical mapping. I'm not sure if how big difference between your techniques and optical mapping.
Oh, well, so for instance, what Han Xiao is doing at Bionanomatrix, where you see large-scale structural variations, but you're not sequencing, but you see the order of structural variants.
Yes.
Right, it's very valuable.
Okay.
But it requires you to have two techniques, the large-scale optical mapping and sequencing, whereas what we're doing will do all of that in one technique. So,
we can discuss it.
Yeah. All right, it's getting nitty-gritty. Any other comments on that topic? Questions from the audience?
I actually have a question. I guess my question would be the importance of read lengths, the importance of seeing all the parts that haven't been annotated or assembled yet in the master human reference genome. How important do you feel that is? It's a bad throw.
You need to fix my DNA.
Okay.
It's a very good question. I think if you do de novo sequencing, the read length is very, very important. And
yeah, we want to only do de novo sequencing.
Okay.
Even for humans.
Okay. So, I mean, yeah, it is very important for de novo sequencing. But I'm not sure what is the cost of the techniques comparing to, let's say, 454. And what is the read length, average read length you can achieve?
Right. We've pulled individual megabase molecules onto it.
We've got a question back there.
Maybe I'll just project that.
It's better because we're recording this for posterity, so make your words wise.
On a commercial level, people online now they can go to a company like 23andMe and for a couple $100 US get some kind of sequencing. I was wondering on a technical level, why is that not full, and how do they do that? And first of all, if you know, and how informative is this actually as far as learning about one's, vulnerability to certain diseases, risks, that kind of thing?
Yeah, as we know, there are two services provided by 23andMe. One is the genotyping-based service. So it collects maybe, let's say, 20,000 SNPs on the market, and it is a chip-based service. It's not sequencing, it's array-based service. So it's mainly looking for the SNPs. And they recently initiated the exome sequencing for the customers. So it's a new service launched by 23andMe. So I think what they do is they see the area of personal genome, and I think it's brought us by the next generation sequencing because it reduced the time to do the sequencing and reduce the cost. And 23andMe are one of the pioneer companies doing this. But I think for now, sequencing is not the problem. It's the problem of interpret the genes, the sequence. So I think it will be the next step.
It's not a high-tech question, it's a low-tech question. Okay. What if I spray this formulation on my skin? Is it a formulation?
Yeah.
What if I spray on my skin?
Okay. We did a safety test. We do a skin test, and we actually did the animal model in Chinese zoo with with your colleague. Okay, Outer Chow. Okay. Because that is one of the issues that they, before we can go to the hospital ICU, one of the major concerns that they had is like whether it will have any long-term effect on the patient, because most of the patients are immune-compromised patients. And actually, in order for them to do it, they actually had to do the monitoring of the neutrophil level before they allow us to actually go in full scale. So we did do all the background safety testing. So, thank you.
You don't have to throw it out. Go ahead. So the enterotype work is like incredibly fascinating. The idea that there are three main types of microbial constituents. What are the odds that there's a fourth that hasn't been found? And why do you think, like a very rare fourth type of enterotype that hasn't been picked out yet, is that possible? And also, why do you think it's like that? Why three enterotypes that are universal?
Yeah, it's a good question. We sequenced 33 individuals for that study, and I have to say the sample size is very limited. And we used the PCA analysis to create the three batches. So there are actually thousands of microorganisms in the human gut, and these three patches are mainly selected on several important microorganisms. So I have to say it's not a mature way to characterize human gut.
Did you do genome sequencing on those subjects and see any correlation between their genomes and their enterotype? Their natural somatic genomes and their enterotype?
We extract the DNA from a whole bunch of microorganisms, and we do the resequencing and align to different genome of organisms. That's why
you also saw the human genome for each patient. You also saw the human genome for each patient?
Yes, but we can filter out by the computing. Yeah.
So why do you think it may settle into 3 universal enterotypes? Any speculation on why?
Oh, why? I don't know.
Okay.
I think it's another field to do the research.
3 times each charm.
Yeah.
I think just a question, because your sampling size is so small. So what are the races of the people that you sample?
The races?
Yeah, are they for
Asian,
example,
American,
Asian,
Australian,
American?
Aboriginal?
All are Chinese. Okay, so that probably answers your question, correct?
Okay.
Because also gut bacteria oftentimes come from the mother, correct? Just like in most animals, come from the mother. Okay.
So they were all Han Chinese? All 33 were Chinese?
Yes.
Do you want to look at my enterotype?
Yeah,
free type.
Yeah, for instance, in the specimens.
Have you looked at the patient with inflammatory bowel disease? The inflammatory bowel disease, I believe.
Inflammatory bowel disease. I think.
I didn't get it.
Because there are certain bacteria that are related to certain type of like for example ulcer, correct?
Yeah.
And other type of like stomach cancers or whatever. So is there any correlation, or just like like for example, there are also work where people have looked at your epidermal fauna, and then they try to see, okay, each person had their own epidermal fauna that you can use them actually as a forensic, right? So what is the motivation of doing this if the population is so small?
This is the aim of the project is to characterize, let's say, how many different kind of microorganisms in the human gut. So that is one of the questions the project is going to answer. And there are several ways to do the genomic studies. First of all, we are going to get a gene pool of the human gut. We are going to see, say, how many bacteria, how many microorganisms in the human gut, and what they are, the ratio of these microorganisms, and what kind of gene is highly expressed or lowly expressed in the human gut.
Now we got a question from Rob.
I just wanted to add something here. You know, the three enterotypes that are found in human gut, they're not racial or nation or continent or geographic specific. It's basically it's everywhere. They do roughly fall into 3 enterotypes.
I thought they were all from the same ethnic.
In this case, his tests were, but I'm talking about. And there is a study a few months old that actually shows that the gut bacteria enterotypes are common to all humanity.
Okay, and those 3?
Broadly, yeah, those 3.
And no one's found a 4th?
Not yet.
Interesting.
Yeah, not yet.
Which
is the reason why they're able to say that you can, maybe some drug and diet combinations will be different for those 3 enterotypes.
It's a question back here.
Just looking at that diagram of the different types of tumors, and the gene involvement. Just looking at that, I saw I realized something about somebody I knew who had begun in the late 1990s with some stomach problems and had progressed through lymphoma and then to leukemia. And looking at that, it all kind of makes sense. Are we learning things from that type of work and those interrelationships that we didn't already know regarding comorbidities? For example, I wouldn't, personally, I don't know anything about medicine, I wouldn't have thought that the stomach problems in the late 1990s would have been related to the leukemia in 2006, but looking at that, I see that the same genes are involved in, colorectal problems and the leukemia. So, maybe all physicians know that these things are interrelated, but are we learning about comorbidities through the sequencing that we didn't know about before, that is then going to give us information about preventive work we can do if we see that somebody has this type of tumor, and then we know, oh, look at this, those same genes are involved in that thing, and so we might know what we could do to prevent that eventuality.
Yes, for the cancer research, the previous problem is it is very hard to differentiate the different stage of the cancer tumor, and even for the same cancer and the same patient, the mutation is dramatically different if the cancer is in a different stage, and that is the problem. People do the sequencing. It will be a combination of different stages. So there are combination of mutations, maybe response to different environment. So I think the single cell sequencing is a very good solution to the cancer research. Surely there are a lot of questions we cannot answer now, but I think it is a very good start for the cancer research.
So I had a totally different direction of questioning. So thinking about personalized medicine and getting the right drug to the right person at the right time. You know, I've done a little bit of work in this area in terms of data mining of databases that the hospital had of what therapies work for what people. And our problem there was just having not enough and not good enough data, basically. Now, it occurs to me that China has many people in it, and I wonder if there's any large-scale attempts to make it a database that can be used for personalized medicine, just of different traits of people and of which therapies have worked for them or have not worked for them for which disorders. Do you guys know of any attempt to make a large collection of data that could be used for data mining in this kind of research?
I think it's an interesting question. The answer is no. Because of concern about privacy. Also, in Hong Kong, the HA, because I think they'll give you a report card about how each physician is doing his job or job. So there's some resistance there. But I think it's going to eventually come. Maybe WHO initiative. But I think there's lots of data already about the pediatrics. We can do clinical trials in pediatrics as well as in grown-up people. So if there's lots of data in the literature, they found that about there's some clues. You have to design the clinical trial more appropriately. I think eventually it will come. I don't think it's there.
Not yet.
I think China probably would do it before anybody else. That's my hunch.
Yeah, that's what I was hoping, but you think they haven't done it yet?
Well, no, I'm not talking with Chinese that often. So I think certainly they will do it. It has to be because they want us to say, no, if they don't do it, I think just like they didn't forecast who's going to get diabetes. There will not be enough. The diabetes is going to take its course in China. There will not be enough insulin for patients. There won't be. So we need to, from this standpoint, we need to put one step ahead.
Are there people working on this in China, within the Chinese government, you think, and organizing this kind of data curation effort? No? Interesting.
I'm looking at the economic data.
Yeah. I think we have time for just one more question, and then we can go to the break. A quick question. Are you able to ask a quick question?
There was a lot of talk about enterotype. For the non-experts amongst us, can you please explain what an enterotype is?
The question is, what is an enterotype?
Sorry, to be honest, I'm not quite sure what this enterotype is.
I thought it just meant like Actually, you know
Actually,
what?
Robbie knows more
So
about
it's just a
that.
classification of bacteria.
Yeah.
You know, an enterotype doesn't mean that it's the same bacteria. An enterotype.
E-N-T-E-R-O-T.
Is it serotype we're talking
Yeah,
about?
an enterotype can have hundreds of thousands of individual species of bacteria. It's just a way of saying that you have a certain type of bacteria that forms into one group versus another type. With the examples are firmicutes.
You know the word enter.
Yeah.
So,
I mean, you know, off the top of my head, we have firmicutes, bacteroides. So these different classifications of bacteria. Just it can have many species inside them.
And the amazing thing is that there appear to be 3 universally different.
It's just a taxonomic term in bacteria.
That's exactly right. It's a taxonomic term in bacteria.
yeah. All right, I think we're going to thank our speakers for an outstanding session. Really, one of the interesting things to me about co-organizing this conference is seeing all the cool stuff being done here in Hong Kong. So, but before the break, Kelly has a brief announcement to make.
Just one.